Alright, Algebra 2, Target 17, I can solve a polynomial equation. Alright, so in Target 16, we saw that if we were given a solution of a polynomial, then we could find the other solutions. But let's say that we don't know any of them, so we need a place to start. So instead of looking at every possible number, we're going to limit it down strategically to just a list of what we're going to call candidates for what could be zeros of this function. And we're going to use something called the rational zero theorem. So basically, we're going to look at all the factors of the constant term at the end of the function, and we're also going to look at all the factors of that leading coefficient in front of that leading term there, and we're going to divide them. Alright, I'll show you an example to show you what I mean in the next slide. So basically, we use this theorem to generate a list of all our candidate zeros or solutions that we can use to help us check and find the actual zeros. And don't forget that a zero and a solution are the same thing. Alright, so now we're going to look at a function and we're going to list all the possible, or the candidate, rational zeros of the function using the theorem from the previous page. Alright, so this told us that we're looking at the factors of the constant term and the factors of the leading coefficient, and we are dividing them. So first, I'm going to list my factors of the constant, and we use P to note what those are. Also, I want to make a note that you're looking at all the positive and negative factors of those numbers. So I'm going to make sure I list plus and minus of each number. So the factors of 12 would be 1, 2, 3, 4, 6, and 12. Alright, then I'm going to look at the factors of my leading coefficient, and they call that Q. Alright, the letters don't really matter, but they're there. Alright, so that would be here, and that's just 1. Alright, so then now they say I'm going to divide each factor of P by each factor of Q, but since Q only has a factor of 1, when we divide 1 by 1, 2 by 1, 3 by 1, and so on, we're just going to end up with all the factors in P. Alright, so the rational zero theorem tells us that these factors right here then are all the potential zeros that this function f of x could have. Alright? Right now we're just going to list them, and then later we'll get into how to actually find which ones will work and which ones won't work. Okay? So now over here, why don't you pause and try to see if you can find all the rational possible or candidate rational zeros for this function f of x. Okay, so first we look at the factors of the constant term, 15. And remember, we're looking at the positive and negative. So I'll look at plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Alright, and then I look at all the factors of the leading coefficient, which again is 1. If there's nothing there, it's a 1, which is just plus or minus 1. So same as we saw over here, if I'm dividing every factor of P by the factors of Q, I'm just dividing all of these by 1, so I'm just going to end up with whatever's in P. Alright, so now these right here are all the possible or potential solutions or zeros to this function f of x. Okay, so now we're going to look at finding those potential zeros and then looking at each one or through them and deciding which ones are actual zeros. So finding all the real zeros or the actual zeros of this function. So first we need to look at all the potential ones. So remember, I look at the constant and those factors. So I'm looking at plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Okay, and then I will be dividing all of those by 1, the factors of the leading coefficient, which is 1. So the only factors of 1 are plus or minus 1. So remember, if I'm dividing all of these by 1, I'm just left with whatever's in P. Okay? So now I want to decide which ones are actual zeros. So I'm just going to do some tests and plug them in and then see if it works out. I test them by doing synthetic division. So I'm going to start with the solution x equals 1 and see if that works. So I'm going to put 1 in the box and I'll do synthetic division with this function. So I list my coefficients in descending order and making sure I'm checking for holes. And I don't have any. Now I will divide. So I pull the 1 down, multiply by the box, and I get 1. 1 minus 8 is negative 7 times 1. 11 minus 7 is 4. Times 1 is 4. And I got 24 as a remainder. Alright, and as we talked about in yesterday's video, if we end up with a remainder here, that means that this is not a solution. So x equals 1, positive 1 is not going to be a solution. Okay, now I'll try a different one. I like to start with 1 and negative 1 and then work my way up because those are most likely, but I guess you could start with any one you wanted to. Alright, so I'm going to try negative 1. And I list my coefficients. And I synthetically divide. I get negative 1, 9, 20 times negative 1 is negative 20. Now I've reached my remainder of 0, so that tells me that x equals negative 1 is a solution to that polynomial, that function. It's a 0. Okay? So I found 1 0, and then if you remember from yesterday, if we know 1 already, we can find the others. Alright, so I look at what's left here, and I power down, and I take what's left of my polynomial, and I keep factoring. Alright, so this is quadratic, so I need to find those two factors. I can put that in the box, put my constant there, my leading term there, and then I'm looking for what multiplies to 20 and adds to negative 9. That's going to be negative 5 and negative 4. And then I'll do my factoring, going up and then coming to the left. So now this quadratic right here factors into x minus 5 and x minus 4. Alright, but remember we need to keep going because we need to find what the zeros are, those solutions. So I set each factor equal to 0. That gives me the two solutions of x equals 5 and x equals 4. Alright, but don't forget that we found those because we'd already found this first one up here. So we actually have three solutions, x equals negative 1, and x equals 5, x equals 4. So make sure you don't forget that first one you found. Alright, see if you can find, using what we just did over here, see if you can first find the possible or the candidate zeros using the factors of the constant and the leading coefficient, and then try some until you find one that gives a remainder of 0. And that would be a solution. Alright, so I'm going to look at my P and Q or my factors of my constant and my factors of my leading coefficient. So for the constant, 14, I have plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14. All right, and then Q is just 1. So if I divide each of these by that 1, I'm just left with this list of the factors of the constant for all my possible zeros. Okay, now I'm going to plug in, I'm going to try -1 right away, and I'm going to look at my coefficients of my polynomial. So I have 1, -8, 5, and 14, and make sure you're checking for those holes. And I'll synthetically divide -1. And now I have my remainder of 0. So that tells me that x equals -1 is a solution. Okay, now I need to determine what the other solutions are. So I look at my quotient that I'm left with here, x squared minus 9x plus 14. Okay, if it helps you remember that you already had a solution, you can bring that down to your paper. Make sure you make a note of that. And then come back here. You have to factor that as quadratic, so we can use the box to find these two factors. So I'll put that term there, 14 there, looking for something that multiplies to 14 and adds to -9. Oh, so I have 7 and 2. I'm going to make them both negative because they have to multiply to a positive. Add to a negative, so -7x, -2x, and then I'll factor, bring up a 2 and an x. To the left, I'll bring over an x and a -7. So I have x plus 2, x minus 7 are my factors. Minus 2, sorry. That's a minus. Alright, so then I will set them both equal to 0. So x minus 2 equals 0. X minus 7 equals 0. That gives me the two additional solutions to what I have over here of x equals 2 and x equals 7. So those are my 3 zeros. And just make a note. So I have -1, 2, and 7. Those all showed up in my -1, 2, and 7 were all in my original list of the possible zeros I could have found. You just kind of do some work to figure out which ones they are. Alright, so in conclusion, to find all the possible candidates for solutions, look at all the positive and negative factors of the constant and divide each of them by the factors of the leading coefficient. We are going to only give you, for now, ones that have 1 plus or minus 1 as a leading coefficient. We will not give you any other numbers there. So basically, you'll just be dealing with the factors of the constant. Alright, and then once you find those, to find the actual solutions to your function, right, you just have a list of maybes, figure out which ones are absolutely yes. You will use synthetic division and divide. You can choose any one to start. And if you get a remainder of 0, that means you have found a solution. And if you do not get a remainder of 0, you just need to try a different candidate. So just keep trying candidates until you get that remainder. Alright, and then once you find the remainder 0, you finish factoring that quotient you get and find your remaining solutions. But don't forget to include the original one you found.